Friends, welcome to the next session of units and measurements. But today onwards we are going to discuss about competitive. Therefore, be ready with your books. First lesson. So they have written their name as dimensional analysis and vectors. Means in this we are going to discuss both dimension formulas and units and measurements lesson competitive. And vectors also some competitive bits we are going to solve. See the first page, they give units, fundamental derived quantities, all those we discussed. But they give SI prefixes. Prefixes they give deci, centi, milli, micro, nano, pico, femto, all these. Just you can see any one or two I am going to write. So you know centimeter. Deci, centi, milli. Deci means 10 power minus 1, 10 power minus 2, 10 power minus 3, 10 power minus 6, 10 power minus 9, 10 power minus 12, 10 power minus 15, 10 power minus 18. So with three difference we have written. So this one we are going to call it as micro, nano, pico, femto, atto, atto. Like that they have given once you can see. Next they give positive powers also. Deca, hecto, kilo, mega, mega means mega star they will say. So mega means 10 power 6. Giga 10 power 9. So like that they have given. So once you can see all those tabular column. And then next they give light year. Page first page, already all those we discussed. Next page number 2, you can see the page number 2 once. Astronomical unit, part second, mass, time, all those they gave. Next dimension, definition they gave. So all these we discussed. Next dimension formulas. So force, work, power, pressure. So yesterday we discussed force, work we wrote, power we didn't write. Now I am going to write power. So dimension formula for power. Power you might have heard. Generally also we will say the amount of work done in unit time. The amount of work done in unit time. Power is equal to. So work by time. So I have given 10 questions for you. 10 questions you can solve. Some people can solve within 10 minutes. Some people can solve within 20 minutes. Some people can solve within half an hour. Who is having more power means who did within less time they will be having more power. So that is nothing but the amount of work done per unit time. So work done unit. Yesterday we wrote units or dimension formula we wrote yesterday. So what is the work done dimension formula? M L square T power minus 2 time T. So M L square T power minus 2. This T is going to numerator. Therefore M L square T power minus 3. So this is the dimension formula for power. P refers here power, not pressure. Pressure also we wrote yesterday. Okay. So next I give fourth one pressure. Pressure means M L power minus 1 T power minus 2. So out of 4 we didn't discuss this power, therefore I wrote this power. Next see they give one big table for you. So 1 to serial number 1 to 52. Out of that 1 to 52 dimension formulas, don't get you don't need to get worried. So don't get panic by seeing those dimension formulas. How we can remember. So some of the dimension formulas those are related to second PU, electric charge and permittivity of free space, capacitance, current density. All those will be going for second PU. In first PU also you don't know all those because still more lessons we have to discuss. So which are important for you, which are useful for this lesson to understand this concept we are going to discuss. In first P also which we didn't cover till now because so many lessons we have to discuss. Those there one by one dimension formulas will be coming. Till then if I talk which dimension formulas for you, you will understand. Those only we are going to discuss including problem solving. Again we will come after completion of all the lessons. Then you can only solve remaining all the bits. Okay. So first one area you know, volume you know, density, velocity, acceleration, force, work, energy. All those you can know. 1 to 8. Ninth one power, only we discussed. 10th one momentum, So that one also yesterday we discussed. Next I am going to give gravitational constant. So this gravitational constant in 10th class I think you might have known gravitational lesson in 9th class somewhere. So that is example 1. In example 1 only the first question they have given. See the example 1 page number 3 before going to see the 11th one. 11th one means 11th dimension form, the gravitational constant. In that say gravitational constant. For that one logic will be there, one speciality will be there for the gravitational constant. We will see that. Find the dimension formula of the following quantities. Universal gravitational constant capital G, the coefficient of viscosity eta, surface tension. Some formula involving these quantities. F is equal to, they gave one equation. F is equal to G into m1 m2 by r square. Second equation they gave, F is equal to 6 pi neta rb. F is equal to 6 pi neta r. So this one we are going to call it as eta of neta. N we have to elongate. So this n we have to elongate like this. That one we are calling it as neta. And next one, S is equal to F by L. S is equal to F by L. So this formula you might have known in gravitation, but this one and this one you don't know. This one will be coming in first PU lesson, properties of liquids. This one also in the same lesson, properties of liquids lesson it will be coming. So at that time we will discuss about this. But can we write dimension formula? We will see. So which dimension formulas we have to find? Capital G, neta and surface tension. Capital G means this dimension formula, neta dimension formula and surface tension. Here S is called surface tension. See they gave below in example 1, you can see the book ones. F means they gave. F is force, M is mass, R is distance or radius, V is speed, L is length. Remaining all, M is mass, R is radius. So this R is either radius or distance they said. V is velocity, S is surface tension we have to find, F is force, L is length. Now first we will find this capital G dimension form. So for this take this equation. F is equal to G into M1 M2 by R. This implies G we have to keep this side, subjective. So R square we can bring this. F into R square by this R square came here. M1 M2 is multiplying here. This side is coming means divided by M1 M2. This is nothing but G. So this G I kept here. R square is coming here. M1 M2 is coming down. Now we have a dimension formula for G. Now G is equal. So what is F here? Force. Force dimension formula. You have to remember force dimension formula. M L T power minus 2. If you forgot means you have to write like this. There is no other way. F equal to MA, mass dimension formula. So A, L T power minus 2. If you forgot acceleration also, then you have to write velocity by time. You know you forgot velocity also, then you have to write displacement by M by T. Velocity is displacement by time. Now definitely you will get force dimension formula. M is capital M, distance is L, T into T by T square. Then you will get M L T power minus 2. I won't say next time. So just if you forgot means how to write, just I am giving idea, because all you cannot remember. At least some dimension formulas you have to remember. Then you can write any physical quantity dimension. Okay. Now force over. Now R is what here? R is distance. Distance means length. Length means L. R square means L square is divided by M1 into M2. M into M. Then you will be getting M square. So one M will be cancelled. One M is cancelled means denominator M is there. L into L square. L cube T power minus 2 by M. Then write this in numerator. M power minus 1. L cube T power minus 2. This is the dimension formula for gravitational constant capital G. I told you one speciality will be there for this. So they will ask in one more question for you in PU only. How they will ask means, give the any physical quantity which is having negative dimensions in mass. Negative dimensions in mass means mass power negative value. Mass power negative value in the entire first PU, you will be having only one and only physical quantity, that is gravitational constant. In second PU you will get, but first PU, this is the physical quantity which is having negative dimensions in mass. So m power minus 1. So m power minus 1 is there. Therefore, mass negative dimensions is there for gravitational constant. Write the any physical quantity which is having negative dimensions in mass. In time, length you will get so many, but in mass, one and only physical quantity, that is gravitational constant. Okay. So that is the dimension formula for gravitational constant. If they ask, write the dimension formula for gravitational constant means, if you remember directly write like this, m power minus 1 L cube T power minus 2. If you forgot means, you have to write from this equation. Okay. Next, in this formula, they are asking neta dimension formula. Then F is equal to 6 pi neta r. 6 pi is constant. Therefore, this will not have any dimension formula. Therefore, neta is equal to F by r. So this neta, they said coefficient of viscosity. The coefficient of viscosity will be getting in the properties of liquids lesson. But remember, this neta is coefficient of viscosity. What is that one? We are going to discuss in next chapter. But we want here only dimension formula for neta. Okay. So force is again ml T power minus 2. This is second time I am writing today's class. Force dimension formula. Therefore, we should not forget force dimension formula. R is radius. Radius means length. L. V is velocity. Velocity dimension formula. L T power minus 1. So L into L. L is otherwise this L you can cancel. Then this L is going to numerator. Then M L power minus 1. This T power minus 1 is going to become plus 1. Therefore, T power minus 2 plus 1. Therefore, neta is equal to M L power minus 1 T power minus 2 plus 1. So M L power minus 1 T power minus 1 is the dimension formula for neta. They get. Okay, next see. Third one. Write the dimension formula for surface tension. Surface tension. So what is surface tension? We are going to discuss in properties of liquids lesson. But they gave me a formula. According to formula, we are going to write. If they didn't give formula, means you cannot write because you don't know what is surface tension now. Now you don't know, but after completion of that lesson, you will be coming to it. So what is force dimension formula? M L T power minus 2. Today this is third time I am writing force dimension formula. Is divided by L means length. Therefore, L will be cancelled. M T power minus 2. So this is the dimension formula for surface tension. They asked three physical quantities dimension formula. So we got those three. Next, example 2. In example 2 also they gave all formulas. First here they asked specific heat, gas constant, Boltzmann constant, latent heat, coefficient of linear expansion, Stephan's constant, Wien's constant. So all these will be related to heat and thermodynamics, and the last 3 lessons for you in your textbook. So last 3-4 lessons, but they gave equations. Therefore, we will try to write one by one. See the first equation. Q is equal to ms delta theta they give. Okay, ms delta theta. Some I will do here. Remaining I will do later. First one, Q is equal to ms delta theta. This S is here specific heat. First one only they ask the specific heat. Yes. Here S is surface tension they gave, but here S is specific heat capacity. Therefore S is equal to Q by M into delta theta. So first you should come to know what is M. Here M they gave mass only. So below they gave what is M. M is mass. Q is heat they gave. Delta theta is change in temperature. Isn't it? Once you can see below, Q is heat, M is mass, delta theta temperature difference. So mass is fundamental physical quantity, temperature is fundamental physical quantity. What about heat? Heat is a form of energy, we will say. Heat is a form of energy, light is a form of energy, sound is a form of energy. All these will be coming under energy. Therefore, heat formula, what we have to write means dimension formula. Energy dimension formula we have to write. Yesterday we wrote potential energy, kinetic energy, energy and work done. Work done energy will have same dimension formula. What is the dimension formula for work done? M L square T power minus 2. That is the dimension formula for work done. Work done energy will be same. Therefore, heat energy I wrote this formula. Mass means M. Next, temperature difference. Temperature difference symbol we wrote either K or K naught. Kelvin dimension according to dimensional formula. So M will be cancelled. So L square T power minus 2 K power minus 1. So this is temperature, it is represented. Whenever K came in dimension formula temperature, T came time, L came means length, M came means mass. Okay, so that one we got first equation Q is equal to ms delta eta. Next we will write next equation. So first we discussed first equation specific heat we got. Now next they gave gas constant capital R. Here capital R is gas constant. See the second equation. PV is equal to NR. R is equal to PV by N. So this R they said gas constant. So gas constant if you want to write means they gave this formula. P is pressure, V is volume, N is number of moles, T is temperature. They gave, see below they gave each and every physical quantity. P is pressure, V is volume, small n is number of moles, capital T is temperature. Therefore, all these we came to know. Isn't it? Pressure dimension formula we came to know. What is pressure dimension formula? M L power minus 1 T power minus 2. V means volume dimension formula. What is volume dimension formula? L cube divided by moles. Mole symbol MOL. Yesterday we wrote. Temperature K. Here in some books data they will write. Okay. So M here L cube, here L power minus 1. 3 minus 1. So 3 minus 1 2. M L square T power minus 2 K power minus 1 mole power minus 1. This mole is going to numerator, K is going to numerator. This is the dimensional formula for gas constant capital R. Next, third one they asked, or C they asked, the Boltzmann constant K. Here K they are calling Boltzmann constant. Okay. So what is Boltzmann constant we will see later. But they are asking dimensional formula for Boltzmann constant. Then K is equal to what is the formula? PV by NT. This is capital N. This is small n. Again, P is pressure, V is volume, T is temperature. But what is this capital N they give? What is capital N they give? Once you can see, capital N is number of molecules. This capital N is number of molecules. Number of molecules means how many molecules present within that gas actually. How many students are present in classroom? Number of students. Number of students means that is number. Therefore, number will not have dimensional formula. Therefore, we should write only PVT. So, Boltzmann constant K is equal to pressure dimensional formula. M L power minus 1 T power minus 2 volume dimensional formula. L cube is divided by temperature dimensional formula K. Okay, same like this. Here mole will be there. Here number. Therefore, we are not writing anything. 1. So this K is going to be numerator 3 minus 1 2. So M L square T power minus 2 K power minus 1. You can't remember this one always. Therefore, you should get by using this equation. You don't need to worry about this equation. This equation will be coming in your heat and thermodynamics or kinetic theory of gases. Last 3 lessons, all these equations will come. Therefore, you won't forget. 4. A fourth one what I get? Q is equal to ml. Q is equal to m. M is mass, Q is heat. What is capital here? Latent heat. Capital they gave one by one. Fourth one they gave the latent heat capital L. Here capital L is latent heat. Q is heat, M is mass. Again, heat is a form of energy, energy dimension formula. What is energy dimension formula? M L square T power minus 2. See, all these formulas we have to remember. So by remembering those, directly we are writing the dimension formulas. Mass. M will be cancelled. L square T power minus 2. So this is the latent heat, not L. This cell is different. This cell is length. This cell is latent heat. Next, delta L is equal to L alpha delta T equation. Delta L is equal to L alpha delta T. Here alpha is equal to delta L by L into. So this alpha they are calling it as coefficient of linear expansion. Correct only? Coefficient of linear expansion alpha dimension. What is delta theta here? Change in temperature. L is length. Delta L is change in length. Change in length means L. Change in length or length. Dimensional formula L. Here also L. Delta theta, temperature. Therefore, this cell will be cancelled. Then alpha is equal to T power minus 1. So that is the dimensional formula for alpha. Next, Stephan's constant sigma. U is equal to sigma A P power 4. Then sigma is equal to U by A T power 4. Here capital A is area, capital T is temperature. What is small u they give? Small u they give below. Once you can see. L is length, U is energy by time. This U is they gave energy by time. Energy by time means now U dimensional formula, energy dimensional formula by time. First we will write dimensional formula for U. So U is equal to m L square T power minus 2. This is dimensional formula for energy. Time. So capital T. This T is going to numerator. M L square T power minus 2. This T is going to numerator means minus 1. Minus 2 minus 1. So m L square T power minus 3. This is the dimensional formula for U. Substitute this U in this equation. Then sigma is equal to U is m L square T power minus 3 by area L square. Temperature K. Power 4 is there. Power 4. L square will be cancelled. Therefore, m T power minus 3 K power minus 4. So this is the dimension formula for sigma, Wien's constant. Next, the last one they ask Wien's constant. This B is called Wien's constant. What they are calling we don't want. We want only formula. That B is equal to what they give formula? Lambda T. What is lambda they gave? Wavelength. T is temperature. Temperature you came to know K. What is wavelength? Wavelength units or have you remembered any wavelength? Wavelength means they will say you got I think in sound lesson. Isn't it? So wavelength. Otherwise light lesson you will get 4000 angstroms. 1 angstrom equal to centimeters. 10 power minus 10. So wavelength means in centimeters, in angstroms, in meters they will write. Means wavelength is representing length. Therefore, lambda is nothing but L. T is nothing but K. Therefore, L K. This is the dimension formula for B. B means there is a Wien's constant. Okay. So this is example 2. So you might have seen so many equations will be coming, but all these equations you have to remember simply each one dimensional formula, that area, volume, pressure, force, energy. Then you can write any equation, any dimensional formula. Okay. Next we will see. So next example 3 and 4, those are related to example 3 related to second PU equations. Example 4 related to first PU only, but some equations we don't know still. Therefore, we will discuss later those. Next is the page number 5, conversion of units. Yesterday we discussed. I gave I think 2 homeworks also for you. One joule is equal to how many ergs. I gave that one as homework. So general formula they gave there. Once I am going to recall, N1 U1 is equal to N2 U2. U1 means unit. Unit means in terms of dimension formula. Numerical value 1. So M1, L1, T1, power A, B, C, some dimension formula. M2, L2, T, some A, B, C. This is the general formula. So you don't need to get panic by seeing this big equation. So yesterday we saw 1 Newton is equal to how many dynes? Here they give a small problem. So H is equal to 6.6 into 10 power minus 34 joule second. H is equal to 6.6 into 10 power minus 34 joule second they give. Isn't it? So joule second in the SI units convert into CGS units. This is nothing but SI unit. This one they are asking to convert into CGS units. So joule second dimension formula we should compare. So what is joule? So joule means joule is the unit of energy. Therefore we should write here energy dimension formula. Second means time. First we will write joule second dimension formula. Next we will see what is this value, how it is going to be converted. Okay. So H is equal to 6.6 into 10 power minus 34. So joule you can write in terms of dimension formula m L square T power minus 2. Second means T. Here T power 1 minus 2. Minus 2 plus 1 minus 1. Therefore 6.6 into 10 power minus 34 m L square T power minus 1. This is in terms of dimension formula. Which system this is? SI system. Now we should convert it to CGS system. Assume this is SI system. This is CGS system. So in SI system n1 value how much they give? 6. This equation 6.6 into 10 power minus 34. So m1 L square L1 square T1 power minus 1 is equal to, so n2 this is CGS system, m2 L2 square T2 power minus 1. This is in which system? CGS system. This value only we should calculate. N2 we should calculate. This is in which system? SI system. You should not write like this, just to or MK system. SI system or MK system. Just to differentiate, I wrote here, we should not write like this, CGS MK. Now N2 is equal to 6.6 into 10 power minus 34. So M1 L1 square T1 power minus 1 is divided by this M2, this value is coming here. M2 L2 square T2 power minus 1. So this is in which system? MK system. This is in CGS system. Okay. Change this. 6.6 into 10 power minus 34. Mass means 1 kg. Here this is 1 gram. Next, this is 1 meter. This is 1 centimeter. Whole square. This is 1 second. 1 second. Whole power minus 1. Second will be cancelled. So to cancel this, either kg should be converted into grams, gram should be converted into kg. They are asking in CGS. Therefore, kg to gram we can convert. 1 kg is equal to how much? 6.6 into 10 power minus 34. 1 kg is equal to 10 kilogram into, here whole square is there, you should remember. 1 meter equal to 10 square centimeter. Centimeter by centimeter. This is meter. 1 meter equal to 10 square centimeters. So now centimeter, gram will be cancelled. Then what will be coming? 6.6 into 10 power minus 34. So 10 cube, 10 square whole square. 10 power 4, 4 plus 3, 7. So minus 34 plus 7. How much? 27. 6.6 into 10 power minus 27. So what will be unit here? Earth second. So minus 27 every second will be getting. That is in CGS system. Joules in terms of CGS, Earths second. So this is the how the value is going to be converted. Only this value is changed. Minus 34 became minus 27. I think you might have got the homework problem if you solve means 1 joule is equal to 10 power 7 earths. I think. You got like this only. 1 Newton is equal to 10 power 5 dynes. 1 joule is equal to 10 power 7 earths. I think you got like that. So that is the how to convert units. That is one of the application. Second one they gave to check the dimension correctness of the given equation. They gave already S is equal to ut plus RT square. Already we discussed yesterday, isn't it? Next, last one, establishing the relation among the different physical quantities. That one also we discussed yesterday. Here they are asking the relation between time period, length, and gravity. Second one already we did, therefore I am not solving. Third one, T is directly proportional to L G. So time period, length, and acceleration due to gravity relation they asked. So yesterday we discussed, is they equal to or directly proportional to, you can write. So L power A, G power B. Here T means time period. Time period is equal to. So is equal to means here some constant we will write. So I will say why we will write. We have to write sometimes why we won't write. So we will discuss. T is equal to. So length means L power A. G means acceleration due to gravity. Acceleration dimension formula. L T power minus. T is equal to L power A, L power B, T power minus 2B. Then T is equal to L power A plus B, T power minus 2B. Compare. Here L power nothing is there. Nothing is there means 0. A plus B is equal to 0. Here T power 1 is there. Here T power minus 2B equal to 1. B is equal to minus 1 by 2. B is equal to minus 1 by 2 means substitute here. A minus 1 by 2 equal to 0. A is equal to 1 by 2. In this equation you can substitute. T is directly proportional to L power A equal to 1 by 2. G is equal to minus 1 by 2. So T is directly proportional to L by G whole power 1 by 2. And T is directly proportional to root L by G. Sometimes we will write equal. Equal to means some constant we will write. So what is the general formula of time period? 2 by root L by. This constant we can't get in relation. That is only one of the limitation of dimensional analysis. We can't get, and dimension formulas will not give any information about dimensionless constant or some constants within the equation. That is one of the limitation. Already we discussed, that one is going to come. I think yesterday I gave one of the problem for it. V, G, R relation, isn't it? So I think you might have got V is equal to root G R. Okay. So this is how to establish the relation and the uses or application of dimension analysis. Next are the limitations. Limitations also we discussed yesterday. Therefore again I am not giving now. So next see example 5. Example 5 just conversion of units gram per centimeter cube to SI system you have to convert. Means gram to kg, centimeter to meter. Just convert, you will get the answer. Example 5 I am not doing. I am doing example 6. Try to do as homework example 5. Example 6. The displacement S of a particle is given by. Here S is displacement. So displacement of a particle is given by this equation, alpha plus beta t plus gamma t square plus delta t cube. Alpha, beta, gamma, delta. And second one V they gave velocity of the particle. V alpha t plus beta t square plus gamma by t plus S, where S is displacement. Find the dimensions of alpha, beta, gamma. Alpha, beta, gamma, delta dimension formula or equation we have to find. So first we will see A. So S is equal to alpha plus beta t plus gamma t square plus delta t. So in this already we discussed homogeneity principle. According to homogeneity principle, Z is equal to X plus 5. Then dimensionally Z equal to X, Z is equal to Y, X is equal to Y. This is according to dimensions. According to dimensions, X equal to Y, Z equal to X, Z equal to Y. Then only we can add these two. Already we discussed. This is called homogeneity principle. Now apply the formula. S is equal to alpha. S is equal to beta t. S is equal to gamma t square. S is equal to delta t cube. So alpha dimension formula we want. Alpha is equal to S means what they said? Displacement. Displacement means L. Distance, displacement, all those will be coming under L. Next beta we want. Beta means S by T. S by T means S is L, T means T. So L T power minus 1. Now beta is equal to L T power minus 1. Next gamma. Gamma is equal to S by T square. That is nothing but L by T square. L power L T power minus 2. T square means T square. Next delta. Delta is equal to S by T cube. L by T cube. L T power minus 3. So alpha dimension formula L, beta dimension formula L T power minus 1, gamma dimension formula L T power minus 2, delta dimension formula L T power minus 3. Now we got alpha, beta, gamma, delta in A over. Now B. So B means velocity. B is here velocity. Velocity alpha T plus beta T square plus gamma by T plus S. T plus or delta plus S. They gave T plus S. Correct only? Now see here. In this, they gave V is velocity. Correct only? Velocity of the particle is given. So in this equation, V is velocity. Yes, they didn't give any information. This S you should not take this S. Okay, that problem is different. This problem is different. In above equation, S is displacement. In this equation, V only velocity they said. Okay, now again we have to find alpha, beta, gamma dimension form. So according to this principle, homogeneity principle, V is equal to alpha T, V is equal to beta T square, V is equal to gamma by T plus S. We will solve one by one. So now alpha equal, here alpha equal to V by T. Correct? What is V? They said velocity. Velocity dimension formula L T power minus 1 by T. L T power minus 1, T power minus 1. So L T power minus 2. So in this alpha dimension formula is L T power minus 2. Next beta. Beta means second equation. V is equal to beta T square. Then beta is equal to V by T square. What is V? L T power minus 1. T square. L T power minus 1, T power minus 2. L T power minus 3. This is the dimension formula for beta. Next gamma dimension formula. In this simple logic we have to apply. So gamma means this equation is on this side, T plus S will be coming. Here T is adding to S. Whenever T is adding to S, S and T will be having same dimensions, isn't it? So x plus y. X plus y means x and y should have same dimension formula. Then only we can add x and y. Here T and S we are adding means dimensionally both are same. Both are same means here T dimension formula is T. Then S dimension formula is also T. Therefore gamma is equal to V by T plus T. T plus then V gamma dimension formula. This is V is equal to gamma by T plus T. Then gamma is equal to V. T plus T means 2T. This 2T is coming here. Gamma by 2T. This 2T is coming here. Velocity dimension form. L T power minus 1. So 2 we don't want according to dimension form. Therefore T. So T power minus 1, 1 minus 1, 0. Therefore L. So gamma dimension formula is L. 2 why we didn't write means in dimension formula we don't need to write constants. That is only limitation. Okay. So we dimension formula will not give any information about constants. So dimensionally, so gamma is equal to L. That is example 6. Next is the example 7. So next is example 7 and 8. So this example 6, 7, 8 very important models in terms of final competitive exam also. So they have given in example 7a. The displacement of a given particle is given by S is equal to A sin omega t minus kx, where t is in seconds and x is in meter. Find the dimensions of omega and k. This is omega. This is k. So omega and k dimension formula they are asking. Okay. So yesterday we gave limitations. So what were the limitations? We gave sine functions, exponential functions and logarithmic functions will not have any dimensions or dimension formulas. Means this is sine something is there. Sine something means this omega t minus kx will not have any dimension. Any dimension means this entire one is equal to omega t minus kx is equal to 1. And this is subtracted from here. Therefore, omega t and kx dimensionally equal we can say. Isn't it? So, here omega t and kx is equal to dimensionless. Therefore, how we will write this one means omega t is equal to 1. That is nothing but dimensionless. Therefore, it is equal to 1. Then omega is equal to 1 by t. There is a t is time. Therefore, 1 by t power minus 1. So about how this omega came, how this equation came, we will discuss in our SHM lesson. At that time, directly you can write omega is t power minus 1. You will be understanding at that time. Okay, now we have to do like this. Again, kx equal to 1. Kx equal to 1 means k is equal to 1 by x. X is in meters degree. X is in meters means length. Therefore, L power minus 1. Okay. So this is dimension formula for omega and k. T power minus 1 for omega, L power minus 1 for k. Next thing. So in B they gave V is equal to V naught into e power minus lambda t. The velocity of particle is given by the V is velocity, where t is in time. Find the dimensions of V naught and lambda. Again, how sine this function is not having dimension. This total value is equal to 1, or sine of the angle is equal to 1. Same like that. Exponential function is equal to dimensionless one, that is equal to 1. Therefore, it is 1 means V is equal to V naught. Then V naught is equal to this V is velocity. What is velocity dimension formula? L t power minus 1. So this exponential is equal to 1 means minus lambda t equal to 1, isn't it? Then lambda is equal to 1 by t. Dimensionally minus is not required. 1 by t means t power minus 1. This is the dimension formula for here. Lambda dimension formula is t power minus 1. This is not wavelength. Okay, just lambda is some constant in this equation. If they give some log x, log omega t, like that they give also, that log function will not have any dimension formula. Dimensionless means that is equal to 1. You should take always. Next, see example 8. They give an equation, example 8. The equation of state of real gas, P plus A by V square V minus B equal to RT. Where T is temperature, P is pressure, V is volume, R is gas constant. What are the dimensions of constant? Small a and b. They are asking dimension formula for A and dimension formula for B. Dimensions of A and B means you have to write the dimensional formula. See this equation. See here P is going to add with A by V square. Where P is pressure, V is volume. So B is subtracted from V. V is volume, B is constant. So homogeneity principle we said. So if we are adding two physical quantities, dimensionally those two physical quantities are equal, isn't it? So therefore P and A by V square are equal. So therefore dimensionally equal. P is equal to A by V square. We can write like that. These two are subtracted. Subtracted means if those are equal according to dimension, then only we can subtract. Therefore V is equal to V. Then V is equal to what is V here? Volume. Volume means L cube. Okay. So that is dimension formula for B. Next dimension formula for A. A is equal to P V square. Present dimension formula. M L power minus 1 T power minus 2. V means volume. L cube square is there. So V refers L cube whole square is there. So M L power minus 1 T power minus 2 L power 6. Here 6, here minus 1. So 6 minus 1, 5. So M L power 5 T power minus 2. So this is the dimension formula for A. So that is example 8. See the example 9. So the viscous force Ft acting on small ball of radius r moving in a medium of coefficient of viscosity eta with speed v is proportional to neta power A r power b v power 6. So example 9. So they gave frictional force relation F V is directly proportional to neta power A r power b V power C. Actually they won't give relation like this, you have to write, but in the question they give neta power A r power b V power. So what is neta? Coefficient of viscosity. What is r? radius, B is velocity. The coefficient of viscosity dimension formula we should come to know. So already we wrote this one in example 1. M L power minus 1 T power minus 1. Force dimension formula M L T power minus 2. Radius dimension formula L. Velocity dimension formula L T power minus 1. If you don't know these dimension formulas, you cannot get the relation. Okay. So this need a coefficient of viscosity. Today's class only we discussed at first example 1 or 2 I think we discussed example 1 only. Example 1 we got meter value you can check M L power minus 1 T power minus 1. I wrote all that. So without knowing all this, you cannot get the relation. So FV, what is FV now? M L T power minus 1 is directly proportional to or equal to also you can write, because whenever you write directly proportional you will write one constant. So neta means M L power minus 1 T power minus 1. M L power minus 1 T power minus 1 neta whole power A. R means radius whole power B. V means velocity L T power minus 1. Next, LHS M L T power minus 2 is equal to, you can write constant or you can write is equal to constant, you will write at the end, no problem. Or write like this one. M power A, expand this one. M power A, L power minus A, T power minus A. This is L power B, L power C, T power minus A. So see how many M terms are there? Only one term. Therefore, write M L T power minus 2. So M power A, L power minus A plus B plus C. All else will be minus A plus B plus C. T power minus A minus A minus C. So compare LHS and RHS. So if you compare M power A, here M power how much is there? 1. So then A is equal to 1. Correct only? Let's compare. L power how much is there? Minus A plus B plus C. Here how much is there? 1. Here minus A minus C. Here how much is there? Minus 2. A value how much you got? 1. Substitute this. Minus A value 1. Minus C is equal to minus 2. Okay. So C we want. Minus C is going this side. Minus 2 is coming this side. Minus 1 plus 2 equal to C. Then C is equal to 1. So A value 1. C value 1. Next, substitute A value how much? 1. So minus is there. Minus 1 plus B plus C value how much? 1 is equal to 1. So minus 1 plus 1 will be cancelled. B is also. A is 1, B is 1, C is 1. Substitute in this equation. Then FB is directly proportional to neta power 1, R power 1, V power 1. FB is directly proportional to neta R. This constant we will write K neta R. This constant value you will be coming to know later. 6 pi neta R. How this 6 pi K means, already that is equation. You will be getting viscous force in properties of liquids lesson. So this is the relation. They ask A, B, C values. So A value, B value, C value is equal to 1. Okay. See example 10 and 11 same models. Therefore, you can try 10 and 11. So I am solving example 12. If momentum, time, energy. This is also same model, but they gave matter wise. They didn't give like equation directly. If momentum, time, and energy were chosen as basic quantities, find the dimensions of mass and force. First, what they give? Momentum, time, energy. Momentum T, time T, energy E. Then by taking as base quantities, find the dimensions of mass and force. So A, mass. So B, force. Okay. So now first we will see A. Mass is directly proportional to. So they are asking in terms of mass, in terms of momentum, time, energy. Therefore, P power A, P power B, E power C. So till now they gave this equation directly, but if they didn't give also, we should write first. Now mass dimension formula. capital M is directly proportional to momentum dimension formula. So you can't take one step also if you don't know dimension formula. What is momentum dimension formula? Product of mass and velocity. M L T power minus 1. Time dimension formula. T. Energy dimension formula. M L square T power minus 2. So M is directly proportional to, so M power A, L power A, T power minus. We have to expand. Next, T power B, M power C, L power 2C, T power minus 2C. LHS only M. RHS, M powers you can add. M power A plus C. Next, L powers you can add. L, so L, only two L's are there. So A, this is here plus 2C. Next, T power 3 are there, isn't it? Minus A plus B minus 2C. Compare LHS RHS. Here M power A plus C, here M power, how much is there? 1. Therefore, A plus C is equal to 1. Next, here L power A plus 2C. Here L power nothing is there. Therefore, 0. Correct only. Next, minus A plus B minus 2C. T power. Here T power nothing is there. So, 0. Next. So here we can see once minus A plus 2C is 0. Then what it is going to become? Minus A minus 2C plus B equal to 0. So this minus A minus 2C is going to right side. And B is equal to A plus 2C. A plus 2C value 0. Now what you got? B value 0. Next, A plus 2C, A plus C. If you solve this one carefully, you will be getting C value. So two equations, two unknowns. How we will solve? A plus C equal to here 1. Here A plus 2C equal to 0. What you will do? Subtract. And now we are subtracting minus minus minus. A minus A 0. C minus 2C minus C 1 minus 0 1. Then C is equal to minus 1. So C is equal to minus 1 means what is A value? Substitute here. So A plus C is equal to 1. What is C value? Minus 1. Then A minus 1 equal to 1. Then A is equal to 1 plus 1. See, A value got, B value got, C value got. Therefore, substitute in equation 1. So M is directly proportional to P power A value how much? 2. P square. B value how much you got? 0 means P power 0, not 0 into. Next, E power. E power C value how much you got? Minus 1. So therefore, M is directly proportional to P square by P power 0 is 1. P square by E. So this is the relation for mass, momentum, time. In the time you didn't get it, isn't it? So same equation you got, simply they have P square E power minus 1. But we wrote like that. So next they are asking force. Again try to do like this. Force, they are asking force. F is directly proportional to, so P power A, P power B, E power C. So as it is. Okay. Now try to substitute according to this one M L T power minus 2. So P means this one. P means here momentum. So M L T power minus 1 over power A, T power B, M L square T power minus 2 over power C. We expand this one and equate both LHS, RHS. Try to write ABC values. Then you will get it. Okay.